Okay, number 6. The integral from 0 to 4, square root of 2x plus 1. This is a u to the n form, where u is 2x plus 1. du is 2dx. So what you're going to have to do to get it into the right form is multiply by 2 and by 1/2. By doing that, you have a u to the n du form. So when you do the integral of u to the 1/2, it's u to the 3/2 divided by 3/2, which is times 2/3, from 0 to 4. Okay? You need this 1/2 and this 2 in order to make it a u to the n form. The 2's will cancel. You're going to be left with 1/3. 4 times 2 is 8, plus 1 is 9 to the 3/2 is 27, minus 0 here, 1 to the 3/2 is 1, you get 26/3. Okay? That'll be 26/3. Number 7, from 1 to the square root of 2, 1 over x. No, it's not 1 to the square root of 2, it's 1 to 2.
1 to the 12.
Yeah, it looks like 1 to 12. I wonder if I meant square root of it. No, I didn't. Okay, 1 to 2, 1 over x. The integral of 1 over x, natural log x, from 1 to 2, natural log of 2 minus the natural log of 1 is equal to natural log of 2, because the natural log of 1 is 0. Okay? And number 8, the integral of secant squared is tangent. Uh-oh. Oh, it's good. It's pi over 4. Whew. I was going to say, we got it undefined. But tangent of pi over 4 is 1. Okay? Everybody all set? Okay. Let's go on. Next page. Number 9. Radioactive iodine. Decreasing exponentially. This is our model for radioactive decay. 5% is the rate of decay. And our initial amount of radioactive material is 100 grams. That is will give us the Q at any time t. That's A. Half-life, you want the time for Q to be 50, 1/2 of what it started to. Divide by 100, you got 1/2. See you, Nick.
Hey, Burns, I'm going to go, yeah.
Okay.
Anything, I'll just watch if I got wrong later. I got to go. So.
Okay. See ya. Take the natural log of each side. Natural log of e to anything is that anything. Trickiest part of the problem is right here. This negative 0.05 is negative 1/20th. You would multiply both sides by negative 20. But this is really bad form. You would make this a positive and take the natural log of 2. Natural log of 1/2 is a negative natural log 2 times this negative. So you get 20 natural log of 2. I mentioned that the other day. That
so how did 20 get there? I'm sorry.
The 20, because this is negative 1/20th t.
Yeah. Oh, so you divide.
So I multiply by negative 20 to get rid of it.
Yeah.
But then this is really bad form, because you should realize that natural log of 1/2 is negative natural log of 2. And that negative together with that negative will give you the positive 20. 10. You're given that area.
Is it 11?
Okay. F of x equals x squared.
Wait, it's 11.
That's
I
11.
thought maybe it was just me. It's
Oh, wait. So
10 is
10
the
is
half-life.
oh, 10 is the half-life one. So I did the half-life one is right here. This is, oh wait, it's actually back here. Okay, there's 10. And that answer is 20 natural log 2 centuries. So that answer to number 10 would be C. Now we're doing 11. Thank you. Yes. We got y equals x squared, y equals 0, the x-axis, x equals 2. This is 2, 4. Okay, we want to whip this around, first of all, the x-axis. When you take this about the x-axis, you're going to generate disks. The volume is going to be pi, 0 to 2, r squared. This is r, the height above the x-axis, which is y. Y is x squared. We're going to square that to get x to the 4th. 12, the y-axis. This is 11 through 13. The y-axis, when you whip this around the y-axis, you're going to generate a shell, a cylindrical shell. The volume is equal to 2 pi. R, the distance from the y-axis, which is x. H, the height of this, which is x squared, dx. Or 2 pi, 0 to 2, x cubed dx. And 13, revolve around the line y equals 1. Here's y equals 1. Negative 1, rather. When you whip this around that line, you're going to generate a washer. Okay? That volume is equal to pi, 0 to 2, big R, which is this distance plus 1, squared, minus little r, this distance, which is 1 squared. Okay?
Can you do it again? I'm sorry.
No problem. Big R is this distance here. Little r is this distance here. This distance here is this distance, x squared, plus 1.
Okay.
This distance is just plain 1. So it's big R squared minus little r squared. R, yeah. Okay? All right. We all set? 14. Integrate the following. 0 to pi. 2 sine squared. To do sine squared, we need a half angle. I'm going to take this 2 out front, but I'm also going to get a half from the half angle formula. Because the half angle formula for sine squared, it's 1/2, 1 minus cosine 2x. Okay? Half angle is 1/2 times this quantity. I put the 2 in here in the problem, so that would just cancel that out. Now, when you do this integral, the integral of 1 dx is x minus. To do the cosine of 2x dx, it's a cosine u form. U is 2x. du is 2 dx. I'd have to multiply by 2 and by 1/2 in order to get a cosine u du form. And the integral of cosine u is sine u. But it turns out it doesn't matter if you put the 1/2 in there or not. Okay? Because even if you mess that up, when you evaluate from 0 to pi, you get a pi here. But sine of 2 pi is 0. Put a 0 in, you get a 0. Put a 0 in, you get a 0. So you get pi. So whether you messed it up or not, you still get the right answer. It's a gift from me to you. Okay?
I got it wrong.
Yeah! Oh, man. Yark. What's that? You think you got it right?
Yeah. No, I have it right.
Oh, did I mark it wrong?
No, this one.
Oh.
And this one is wrong.
Oh.
But I put it right.
All right, so what are you telling me? What's the bottom line here? Is that your correct score or not?
And this one is my correct score. And this one, I got it right and I surprised because I wasn't sure.
Okay. So you're okay. All right. Okay, 14. Let's go to 15. 15 is 0 to 1, x e to the x. This is an integration by parts problem. U is x, the dv is e to the x dx. Du is dx, v is equal to e to the x. So the integral becomes uv x e to the x minus the integral of v du, which is x e to the x minus e to the x from 0 to 1. Put a 1 in here and you're going to get 1 e to the first. That's e to the first minus e to the first. You cancel out. Minus. Put a 0 in here, you get a 0. Minus plus e to the 0, which is 1. Okay, you with me? That face says, no way I'm with you. What do you say? Daniel, you got a question?
So e to the 1 is 1?
E to the 1 is e. E to the 0 is 1. Okay. All right, 15. Let's go to 16. The integral of sine cubed. The way to do sine cubed is to split off one of those sines, leaving sine squared behind. Why do such a thing? Because you can convert those sine squareds to 1 minus cosine squares. Now, you've got two integrals here. The first integral is the integral of sine, which is a negative cosine. And then you have a minus cosine squared sine. That's a u to the n form, where u is cosine, and the du is a negative sine. So you got to get a negative sign here. Well, you got a negative one out here. I think the best way to look at this is multiply this by negative 1 and this by negative 1, which will make it a plus. Then you have u squared du. And the integral of u squared is u cubed over 3. And it's going to be a plus, because you had to multiply by negative 1 to get your du here. And this turns that, multiply by negative 1 will change this into a plus. Hopefully that's reasonable. Put 0 to pi in here. Cosine of pi is negative 1, but it's the opposite of that, so that's a 1. You got the cosine of pi here, which is negative 1 cubed is negative 1. Minus plus cosine of 0, which is 1. Minus cosine of 0, which is 1, minus 1/3. So after all that, you end up with 2 minus 2/3, okay, which is equal to 4/3. It's a little messy in there, that's for sure. And that's what it is.
Do you think when you have it on the real test, you're going to switch around and make it cosine?
Probably. It's probably what I will do. I don't guarantee, especially since you bring it up, but probably. 0 to pi over 4. Tan secant squared. Well, hopefully you know that the derivative of tangent is secant squared. So this is a u to the n form without doing a heck of a lot. Let u equal tangent, the du is secant squared. So u du is what you have here, the integral of which is u squared over 2. Tangent of pi over 4 is 1. Tangent of 0 is 0.
I don't understand.
What? Okay, here. Let u equal tangent. The du is secant squared. You've got that du right here. That integral becomes the integral as x goes from 0 to pi over 4, u du. Because you've got that du to go with it.
And then how do you get the tan squared x?
So, what's the integral of u du? That's u squared over 2. But you replace u with the tangent. That's how you get tangent squared over 2. Okay, and then you let u go back to x's again. You could have changed your limits of integration to u limits, but oh well. Either way. Okay, what's that? 18. Find the appropriate trig substitution. Let x equal tangent theta. Why? Because tangent squared plus 1 is secant squared. That's why. That enables you to get rid of the square root. 19. Find the sum of the constants. You want to use the partial fractions on it. So for a, multiply by x minus 1, let x equal 1. 1 minus 2 is negative 1. A is negative 1. Solve for b. Multiply by x minus 2, let x equal 2. 2 minus 1 is 1. b equals 1. Therefore, a plus b is 0. 20. The sequence n over n plus 1. Sequences converge as long as their nth term has a limit as n goes to infinity. The limit as n goes to infinity of n over n plus 1 is 1. Therefore, the sequence converges to 1. Now, if this had been a series, it would diverge. Exactly. Okay? The sequence converges to 1, the series would diverge. 21. Find the sum. Boy, I think I've done this problem 18 times in the last couple of weeks. Yeah, I think I am going to change it. Maybe I'll keep it the same just for laughs.
That'd be nice.
I memorized 2/3.
Yeah, 2/3.
Like 2/3.
Yeah, there it is. All right, the sum is equal to a over 1 minus r. A is 1. R is negative 1/2. Okay, that's the common ratio. That's what you multiply each term by to get the next term. So it's 1 over 1 minus a negative 1/2, 1 plus 1/2, which is 3/2, and 1 over 3/2 is, like Yarick says, 2/3. 22. Oh, I'm hoping to squeeze this in here. 22. The series. N equals 1 to infinity. Negative 1 to the n over n cubed. It's an alternating series. What you do is examine its positive series first. Well, gee, the positive series converges because the difference in degrees is 3. More than enough to cause the series to converge. Therefore, the alternating series converges absolutely. Very nice. Okay. 23. That series of 2 to the n over n cubed, since 2 to the n is exponential, it increases faster than this polynomial. Therefore, these terms are not even going to go to 0. They're going to infinity. Therefore, that series will diverge. The terms are not even going to 0. 24. Find the radius of convergence. Here we go. You find radius of convergence by using the ratio test. Let's do it. Take the limit as n goes to infinity. Am I still on there? Yeah, I guess I am. Okay. X to the n plus 1, n plus 1 cubed, x to the n, n cubed. Limit, n goes to infinity. X to the n plus 1, n cubed. X to the n, n plus 1 cubed. Limit as n goes to infinity of x. Now, that's subtract the exponents. N cubed over n plus 1 cubed. If you multiply those out, the third degree ratio leading coefficients is 1. That limit is 1. There are no more n's. As n goes to infinity, we get the absolute value of x. We want that to be less than 1. This is the radius of convergence, 1. Now, if you think about that, you may say, Burns, you bozo guy, you told us that exponential forms increase faster than polynomials. You got an exponential form up in the numerator and a polynomial in the denominator, and that's true. The thing is, though, if x has an absolute value less than 1, if x is a fraction, then what happens? 1/2 to the n becomes 1/2 to the n. And that comes down in the denominator, causing those terms to go to 0 really fast, because you got an exponential and a polynomial in the denominator, as long as that's a fraction between a -1 and 1. Yes?
For the n plus 1 to the third,
Yes.
how does that cancel out?
That cancels out because what happens... Shoot, I'm going to use another piece of paper.
No, you can do it right underneath.
No, it's too squishy. I can use another piece of paper. It's not a big deal. Here you go. Oh! I'm losing it now, so, ooh, boy. Okay, here. When you take a look at this limit as n goes to infinity, we ended up with n cubed over n plus 1 cubed. One way to look at it, I suppose maybe this way is a better way to look at it. N goes to infinity here. You could write this way. Okay? And n over n plus 1 goes to 1, and 1 cubed is 1. Or you could look at it this way. When you multiply this out, this is what you get. Okay? And these are same degree, and the ratio of their leading coefficients is 1. So that limit's 1. And you could prove that limit's equal to 1 a couple of different ways. One way is you could use L'Hopital's, and you see with L'Hopital's after a couple of iterations would give you 1. You could also see that if you divide numerator and denominator by n cubed, you're going to get a 1 here, you get a 1 here, and everything else here will have n's in the denominators, which will go to 0 as n goes to infinity. You'll get a 1 that way as well, okay? No matter how you cut it, that limit is equal to 1, and hence it just goes away. And finally, 25, confused over 25. Why so many people got 25 wrong? I don't get it. Find the error when using the first three. Now, you're going to use the first three non-zero terms to estimate cosine of 1. All right, so here's the deal. Cosine, being an even function that it is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, okay, minus x to the 6th over 6 factorial, okay.
Yeah, because I almost...
Wait, what did I give for an answer?
B.
Oh, good. Okay. Whew. I thought for a second
I
there.
almost did the sign one. Maybe a lot of people went to the sign.
Oh,
I did the
man.
sign
7 factorial.
Oh, you did? Oh, no. So the cosine of 1 is 1 minus 1/2 plus 1/24. But we didn't even care about that. What we cared about is what kind of error that you get. And it's going to be a 1 over 720. Because that's the next non-zero term. Okay? That's the error. Yeah, yeah.
I chose B, and the last minute I was like, no, C.
Oh, man. Oh, the 7 one. Yeah. Well,
Now I know.
okay. All right. That's your test. The test on Thursday will look very similar to that. And get those labs in. If you want to try for homework, there's only a couple of people that did really well on the homework. Gessner did great, but the homework on web assign, I don't know, it's a pain in the neck.
It's helpful.
Yeah. Okay.
So you want everything done?